So on Monday, Jack and Jill walked from their home up a hill to get to the bus stop. They walked 4 yards every 3 seconds. So it says write an equation to represent the distance d that Jack and Jill walked over time. So they walked 4 yards every 3 seconds. Now distance, the ratio, the distance formula is always distance equals the rate times the time. Okay? So what we know is that if they walked 3 seconds, this should equal 4. So what we're going to do is that ratio of 4 over 3 is our coefficient, right? That's a rate of change. So this is what we call a rate of change. How far do they go over how much time? And we see that d is what we would call the dependent variable, because the distance they travel depends on the time that they travel, where t is what we call the independent variable. Okay? And remember, whatever I write down, you guys write down. So I've written an equation. Now what I do is if I want to figure out how far that Jack and Jill walked, I just got to know time. If I know the time, I can plug in the time and figure it out. So question 2 says, does this situation represent a proportional relationship? And if you remember, yes it does. Yes. It has a constant rate of change. In other words, it'll always be 4 yards to 3 seconds. And remember, that is a linear relationship, so it's linear. Now, I'm going to do something for question number 3, and we're going to do some long math, and then we're going to do a shortcut on the calculators. All right, so let's look at this. It says for question 3, it says complete the table. It says complete the table and then graph the points. Finally draw a line to represent the relationship between the time Jack and Jill walked. So I'm going to say if they've walked 0 distance, what do you think the time is? 0, right? Now where I get that from is if I take my formula and I say d equals 4/3 times t, and I say d is equal to 4 over 3 times the time, which is 0. What's 0 times 4/3? 0, and that's how I get this answer. So my distance is 0. Now to do the next one, the time spent after 1 second, how far do they go? Well, I start with the same formula. I'm going to say d equals 4/3 times t. But I'm going to plug in the number 1. So in here, I'm going to plug in the time, which is the number 1. Now, what's 1 times 4/3? 4/3, right? So over here, I'm going to say 4 over 3. How do you think I get the next one? Well, I'm going to start with this equation, d equals 4/3 times t, but now I'm going to plug in 3. So right here, I'm going to plug in 3. Now, I can do this on the calculator if I want. So you say, well, Mr. Adams, it's fraction. How do I do fractions on the calculator? Not that hard to do, actually. So what I'm going to do is I'm going to go to math. See how it says fraction? I'm going to go all the way over here till it says fraction, and then I have the numerator over the denominator, and I'm going to plug in 4 over 3, and then I'm going to say times 3. Hey, what does it equal? 4. So now what I'm going to do is I know that after 3 seconds I get 4. If I get 4 yards in 3 seconds, how many seconds do you think it'll take to get 8? Yep, 6, just by guessing. Now, how could I double check that, though? Calculator. So I'm going to take my calculator, and I'm going to hit math, go over to fraction, choose the fraction, and then I'm going to type in 4, go down here, 3, times, now this time, instead of 3 seconds, what do I plug in? Now that's what we want. We're guessing to see if it's 6. Okay, so it is 8. So when the time is 6 seconds, in other words, when this is 6, I get 8. In other words, D equals 4/3 times 6 equals 8. Okay? Now I can do this again. The next one says 7.5. Okay, so I'm going to take my calculator and I'm going to go to fraction by hitting the math button. I'm going to scroll over to fraction. I'm going to choose the fraction setup. I'm going to say 4/3 times 7.5. What do I get? 10. In other words, if I go through and I do the math, if I say D equals 4/3 times 7.5, I will get 10. Now you could do this by hand too, so I'm going to do 9 by hand just so you guys could see that. So for this last one, if I say D equals 4/3 times 9, isn't 9 the same as 9/1? Yes. So now, how do I multiply two fractions? I just multiply the top across the top. So what's 4 times 9? 36. And what's 3 times 1? 3. Now, we want a unit rate. So how can I take 36/3 and make a unit rate for that? Divide it. Very good. So what we're going to do is we're going to say 36 divided by 3, which is 12. So this will equal 12. Now what this means is, this is like the x comma y. You could think of this as x and this y. So these are the points on the grid 0, 0, 1, 4/3, 3, 4, and so on. So now if I go to graph this, I'm going to come over here and I've got 0, 0. That's the first point. The next point, I'm going to go over 1, and then 4/3 is 1 1/3, so it'd be about right here. And then the next one, when I go over 3, I'm going to go up 4. In other words, this point is 3, 4. This point is 1, 4/3. And this point is 0, 0. Okay? Then the next point is going to be, I'm going to go over 6, and then I'm going to go up 8. So I'm going to go up 6 over 8. Or I'm sorry, over 6, up 8. So this is the point 6, 8. And then our last one is 9, 12. And I skipped the 7.5, but it's 9, 12. Now, if you graph your points properly, these points should form a line. Okay? So if they don't, that just means that you got to check how you graphed it. You got to graph it properly. Remember, we're graphing x, y. Always in alphabetical order, at least in a high school math class. Always x, y. Okay? And then I want you to take your ruler. This is important. I want you to take your ruler and we're going to draw a straight line through these points. And we want to be very precise in how we do it. And maybe make the dots bigger along the line so we could really see them. Now what this represents the equation D equals 4/3 times T, where 4/3 is the coefficient or the rate of change. So we would call this the slope or rate of change. Does that make sense? All right, so then it says, what is the unit rate it means in terms of this situation? So we said that D is equal to 4/3 T. So what we want is we want the unit rate of 4/3. How do I find that? I'm just going to take 4 and divide it by 3 on my calculator. So if I turn my calculator on, I'm just going to say 4 divided by 3, and I get 1.3 repeating, right?
Yeah.
Okay. Now, we have to be careful. Mr. Adams said that the unit rate is usually have a 1 at the bottom. I think what they really meant to say was rate of change, because unit rate can mean unit per unit. In other words, we were doing 4 yards per 3 seconds. So unit rate could be interpreted as, what is it, how many yards per 1 second? Well, that would be 1.33 repeating yards per 1 second. Okay? So Carnegie says this is the unit rate, but if you ask a mathematician, they would say this is the unit rate. So explain why Tanner's reasoning is incorrect, why the graph goes up as far as you move from left to right. So it says, Tanner, this graph goes up from left to right because Jack and Jill were walking up a hill. So Tanner's not correct in his assumption. In other words, he's saying, oh look, you got a graph, this is representing the hill, and Jack and Jill walked up the hill. That's not what it represents. The graph represents the distance over time. As time increases, that's your left to right, your distance increases. Goes up. So the graph represents the ratio of distance over time as the time increases. In other words, as you look at the graph from left to right, the distance increases, which means it goes up. In other words, if I look at this graph, as I go across this way, my distance is going to increase. So the distance increases as time increases. Okay?